if that's x to the first, is that natural log? And then this would just be the antiderivative cosine, which is sine, but you'd have a 1/8 kicked out, right? And so we could go down here to the answers for number, whoops. Why do I go from number 3 to number, is that number 7?
Yeah, you like.
That's weird. Yeah, so anyway, so there's the answer to number 4, right? Because there was a 6 there, you kick out a 1/8, so that'd be 6/8 or 3/4. So those are the basic antiderivatives, just the page 333, here's the rules, you need to be able to do. All right, and then if you go back up here to number 5, 5 would be a u substitution. Now it's also a definite integral where you have to evaluate it, do fundamental theorem, so there'll probably be a couple of the 10 that are where you have to do that. So that the only difference is you do the antiderivative instead of putting on the plus c, you do the right bracket, put your 1 and your e, and plug those in. But this would be a u substitution. The reason it would be a u substitution, you got an inside. You could let u be 6 minus ln x. The du would be a 1 over x, which is sitting right there. That'll take care of that x that's down there. And so that's why that works pretty good for a u substitution. So if you go down here to the answer to that one, okay, so we let u be 6 minus ln x. The du is a negative, which would come out here. So you end up with 1 over u squared, which was that squared or that. So you raise that up 1, it's -1, divide by -1, will cancel that. It just ends up being u to the -1 or 1 over u. And then I went ahead and changed the 1 and the e. Remember, we talked about that where the integral had been the integral from 1 to e. So the original integral was from 1 to e, so I took the e here and I plugged it into here. Well, ln e is 1, 6 minus 1 is 5, so that changed to a 5. And then I plugged the 1 in, ln 1 is 0, 6 minus 0 is 6. So that's how that ends up being those numbers. Okay, so the antiderivative is this, so I just plug in a 5, 1/5, plug in a 6, 1/6, I get that. Or the other option is once you get your antiderivative 1 over u is to put that back in. I'm okay if you do that too. So if you want to plug the 6 minus ln x, because that's what you do when you're doing a regular indefinite integral, right, is you go back to your x's. So if you just want to be consistent with that, put your x's back in and then use your 1 and your e. Same answer, either way. Okay? All right. So there's going to be some u substitution. That's probably the majority of the problems. Probably half or more are going to be u substitution. Okay? And then we go to number 6 here. And number 6 was an integration by parts. Because it's not a basic antiderivative because they're multiplied. You can't just do them individually. It's not a u substitution because you try to pick a u and you want the du to be setting right there and it's not. There's no good u to pick there that would work. So really the only thing left is integration by parts. And I can pretty much tell you that integration by parts is going to have this look to it. It's going to have like an algebra with an exponential or an algebra with a log or an algebra with a trig or a log with an exponential or a log with a trig. It's not going to be a exponential with a trig because that's that one we saw did the repeating thing, right? They're pretty much going to look like that, right? I mean, those are the simplest variations, but here's an algebra like a power with a log. Now, the difference is we said, remember, if this was x and then I had, right? So I just get done telling you that if you have an x with a trig like that, integration by parts, well, what would you do on one like this? That's a u substitution, right? What are you going to let the u be on this one? The x squared, right? Again, you pick a u substitution because if you can pick the u and have the du sitting right there, that's what you want. So you let u be x squared, the du is 2x dx, and then you have that x dx sitting right there. So this would be a u substitution. But if you get one, like this one, right? If this had this one wouldn't really work because that plus 8. But anyway, right? So, I mean, just because I say if it looks like this, that's integration by parts, understand, you check u substitution first. But none of these, since they're all just plain x's in there, there's not going to be any good u substitution you can pick. All right, so back to this one. You got algebra and log And we know in Liate, the thing you pick for the u is log is always going to be your first choice. So there's a log here, so you're going to let u be the log and dv be the other stuff. So we go down and check the answer to that one real quick. Right? We let u be the log, we let dv be the other stuff. Your du would be that. Here would be your v. So it's a little bit complicated. You got a power rule, and antiderivative 8 is 8x. Don't forget, sometimes people leave off that 8 because you're thinking derivative in your head. It's antiderivative. So u times v, so I'd put that in parentheses, minus v du. So you're going to take this times this. Well, you should distribute that. So you distribute that 1 over x through there. 1 over x would cancel one of those x's, be x to the fifth. 1 over x would cancel one of those x's, or that x right there. So you'd have this integral. So now you just do that antiderivative. That'd be a simple power. Raise that up to a 6, divide by 6, and then stick on an x right there. So that's number 6, yes?
If we had the natural log distributed, would that be wrong?
Nope. It's okay. That's just rearranging your answer. So if you want to distribute that right there, yep, you can do it, but you don't have to. Okay? Really not much in the way of simplifying. I mean, again, if there was an x out here, even then, distributing to me is just rearranging, so I don't think that's important. Okay? So there isn't nearly the worry of doing that like there was on the derivative gateway. I was going to say something. Oh, Emily was pointing out, did anybody else get on the website and have trouble on your Chromebook getting blocked? She said on that one where it said you get lots of practice, and there's like 50 of them or something. But she was able to do it for a while, and then all of a sudden, I don't know. So you might have to get on a different computer, like a home computer or something. But I don't. There's a lot of good problems in the book, so it's not like we need to do the website, right? That 23 through 73, there's tons of them. But that is a good website if you get it. And you could search for some other ones. I haven't found anything else right now, but I haven't really spent very much time looking either. So, so see if there's some other new stuff out there. So I'll try to do that. But there's quite a few practice ones in the book you can do also. All right. Just quickly then, because I want to spend a fair amount of time giving you a chance to do some, and then also giving you some new ones to try to let you ask questions too. So again, some basic, so number 7, some basic. Now here I would distribute this, right? Because you can't do a product here, so we need to distribute that, and that'll just turn those into powers, okay? And so this would be more of a basic one, even though those are a little bit of work to do, and the answer to that one is right here, okay? And again, you've got access to this document, so you can look those up. 8, I would split that apart, right? This is one that could cause people problems, but it really is pretty simple because you just do 5x to the 4th over x, that's 5x cubed, and plus 1 over x, and this is simply 5/4 x to the 4th plus ln x, and then it would be from 1 to e. So there, and then you just plug those in. And yes, you would have e's in there. So you on your test, you'd have 5/4 e to the 4th, you plug a 1 in there, ln 1 is just 0, minus, and now you put an e in here, ln e is 1, put a 1 in here, that'd be 5/4, put it in the wrong place, put a 1 in here, that'd be 5/4, plus, okay, back up, I screwed that up, sorry, okay, plug an e in here, you get this, plug an e in here, ln e is 1, that's a plus, and then minus, now plug a 1 in there is 5/4, plus, and then ln 1 is 0, okay? And so now you should simplify a little bit here. 1 minus 5/4 is what? Negative 1/4, and so something like that, okay? So you split that apart, and then go from there. So that's also just kind of a basic antiderivative, but with a little bit of algebra to do at the beginning on it. Okay? What about this one? What'd you do on 9? Kind of an interesting one. It's an integration by parts. What if that thing in the bottom would have been just an x? then it's a u substitution, right? If the thing on the bottom is an x, you let u be the ln x, the du's 1 over x dx, which would be sitting right there. It'd be a real simple u substitution. But since it's not, then I would bring this x negative 2 up like this, and then I would make that an integration by parts. There's your algebra, there's your log, so you'd let u be the ln x, and you'd let the dv be the x to the negative 2 dx. So that's a power with a log that's not a good u substitution one because of that x squared. If it had been an x, it would have been a great u substitution. Because it's an x squared, I would do that one as an integration by parts. Okay? All right. Number 10. What was this one? Well, it's a u substitution, but it's going to be a what? It's an arctan, right? You want to be on the lookout for 1 plus something squared or square root of 1 minus something squared. You always want to be on the lookout for those, right? Doesn't mean they're always going to be that. But this one, since there's a 3, now if there had been an x here, that would have been different, right? If there's an x here, then I'd pick you to be this bottom because I'd have 8x dx, and that would have taken care of that. But there's not. So I look at this, and I see a 1 plus something squared. Now, what's the u need to be then so I get something squared? 2x. See, I'm looking at that bottom, and I'm seeing this. Right? And so I can pull that 3 out. I'm going to let u equal 2x. So I get 2 dx. Then I can move that over. So now what I'm going to end up with is a 3 out here. I'm going to end up with a 1/2 over here. And then I'm going to have 1 over 1 plus u squared du. And that's going to be an arctangent. That's going to be an arctangent. Okay? So what are you looking for? That's the key. And then 11, this last one, that's a simple u substitution, isn't it? Because you got the u as the inside. And you'll get 6x squared dx. There's an x squared sitting right there. And you got it. Okay? So, all right. So that's pretty good practice on, or pretty good review of just the concepts of what's going on. I just think we need to practice a little of that, some more. So, how about you guys? What did you practice in the book or the website or whatever that you ran into that you had questions about? Which one, Jamie? Is this one in the book?
No, it's
in the packet. Okay. Okay, read it to me. 53, you said?
23.
23 in the LH packet. Okay, read it to me.
The square root of x divided by the square root of x minus 3.
Like that?
Yes.
Okay, and an indefinite integral?
Yes.
Okay. All right, good one, because this is actually something I wanted to talk about, because this is going to get into that solving for x business. Okay? So, and this does have kind of a different little twist on it. So again, this is the key. This is good. Extra practice, you're going to run into these things that we can talk about. So what do you suppose, so what are our options? A basic antiderivative. Can we split this apart? Can't split this, can we, the way it's written? If it was flipped around, yes, then I'd be splitting it apart. But nope, can't do it. So then you think u substitution. What would be a potential u? The bottom, right? I would let u be the bottom. Okay? That's usually the next thing. Inside, bottom. Okay? Those are the things to try. So I would go with that. Now, you might not be seeing where that's going to lead you just right now, but I think that's where I would go. Because number one, u substitution is the majority of the stuff we're doing. If you don't know what to do with the u substitution, you jump to that integration by parts, you're doing it way too much. Remember what I say, 2 times? If you're trying to do the UDV stuff, the integration by parts, more than twice, you're doing it way too many times. Okay, way too many times. Sebastian, you all right, man? Hang in there now. I want to write this down. This is a good one. All right, so we get this. So now we want to do the derivative. This is x to the 1/2 right here. Okay, so du equals what? 1/2 x to the negative 1/2. The 3 would go away. Dx. And I could rewrite that a little bit. That'd be 1/2. That'd be the square root down here. Dx kind of thing, right? Okay? So, now, some of you may be sitting there saying, no, wait a minute. We said we should pick a u so that the du is setting there. Well, that's the best case scenario for u substitution. That's really, we see that, man, that's what we want. That's u substitution. But it doesn't mean it has to be. Because look at this. So you might be going, wait a minute, that gives me a square root of x on the bottom. And I've got a square root of x on the bottom, but it's got a -3, which really messes things up here. I can't just -3 to that, so I can't do that. I got a square root of x on the top. That's no good. Ideas, or do we keep going with this? What's going to happen, Logan?
Find what radical x is.
Right here. Right? So in other words, but this is going to be interesting. So yes, I agree. Remember, it's kind of that solve for x situation, isn't it? Okay, now watch this. When I go to substitute, and I don't know, Jamie, if you had gotten all this and you were good, and then you ran into roadblock, because there is going to be a roadblock here. Here's where this problem really brings up where this circling becomes really important. Because I can get rid of that and replace it with what? U. That's easy, right? And this, I agree with Logan. What is this equal to? U plus 3. If I do u plus 3 equals square root of x, right, square root of x is u plus 3. So I can do that. Now, what do I do in a situation like that then? What would I do? Why is this better? Split it apart. Am I ready to do that? No. No. Macy, say it again. Notice how I haven't circled the dx yet. I have not subbed out the dx. I can't just stick a du on here right now, because that'd be like saying what? That dx was equal to du. And is it? No, not at all. I've got to get that dx out of it. How do I do that? I need to solve for dx. So we've had problems where we had to solve for x to get it out of there because we had an extra x. Well, now we've got like an extra dx, right? Not an extra, but we got a dx there that we have not taken into account. So how do you solve for dx? I've always told you up until now, you don't want to move these x's over here. You don't want to mix up x's and u's. But in this case, it's actually going to be okay. Because look what happens. If I multiply this over here, right? Oops. I stick by my original statement. You don't want to mix x's and u's. But what is square root of x? U plus 3, right? I don't want it, so since I just figured out now that dx is this, I don't want to write 2 square root of x du over here. I need u's, right? Well, we know that square root of x is equal to u plus 3. So I'm going to make another substitution right there. So I know that dx is actually all of this. So I can put my 2 on the outside. I can do a u plus 3 here and a du. Everybody see that? So now it's just algebra at this point. What would be a better way to write this? U plus 3 squared. Over u, right? Now what? Now what? Can I split it? Remember, my plan was going to be to split it apart, right? Can I split it apart now? No, but what could I do so I could split it apart? Multiply out the top. I got to multiply out the top. Okay? So this becomes u squared plus 6u plus 9 over u du. And then this becomes u squared over u would just be u plus 6u over u becomes 6 plus 9 over u du, right? And then, let me put this in blue. Now, notice I've written my integral symbol all the whole way down here, haven't I? I brought my integral symbol all the way down because I've never done the antiderivative yet. All I've been doing is algebra. Now I'm ready to do the antiderivative. So what's the antiderivative of u? 1/2 u squared. Antiderivative of 6? 6u. Antiderivative 9 over u? 9 natural log of u. And then, of course, plus c. And then I'm out of room, so let me go up here. So 2 times 1/2, that would cancel. And then u was what? Was this? So this is going to be root x minus 3 all squared. Plus 2 times 6 is 12 u. So that's going to be root x minus 3 plus 9 ln, and then it bars root x minus 3 plus c, piece of cake. Right? Now, we always talked about the gateway test, some easy, some medium, some hard, so this one would probably be easy. I mean, medium. Yes, it's 18. Look at that. See, and I missed it. Well, it's a good thing I can miss 2 and still get 100. All right, it is 18. 2 times 9. Forgot the 2 times 9. Right? See, it's cases like, that's why you want to study so hard for this thing, because if you're going to get 8, if you're going to get 8 out of 10, you got to figure you're probably going to do that one time, where you're just going to forget to multiply something and do something stupid. So that's going to give you a 9. You know, so you better know them really well, you know, and hope you don't do something stupid more than twice. Right? All right. Yeah, that would be bad to go through all of that and then forget to do 2 times 9. That would be frustrating. Especially if that was the one that gave you a 7 instead of an 8. Okay? You'd rather get a 2 than a 7. All right. Okay, so that's a little different twist on the old solve for x thing, but it's the same idea. Solve for dx. Actually, I had to solve for dx because we subbed everything out except the dx, and that's why you cannot forget about it. You cannot forget about it. That's why I think on some of these problems, the circling, I don't do it all the time because sometimes it's very obvious, but I think that can really be important, and that can happen. Doesn't happen a lot, but it can happen. And it happened. The packet had a number of those. That 310, page 310, had a number of them where you had to solve for x. So it's good practice on these distributing ones, fractional powers. That happened a fair amount on that LH packet. So that's good because you're probably going to see some of those. So that's a good place to try. Okay, what else? So we got another one. That was very good, Jamie. Thanks for asking about that one. That was good for people to see. Anybody else? Anything on the website or anything you'd rather get into? Not too bad. I mean, I can't really think of any off the top of my head of something we haven't talked about.
It was x ln of x over e to the x.
X, L, oh. Yeah, we're probably not going to have to do this one.
Yeah, I didn't try it.
Yeah.
It's one of those rare cases where it doesn't have an
No. What's that?
Could it be for today? It does have.
Oh, could it be for today? Yeah. Type that in your. Somebody got a calculator out real quick. Type that in your calculator. See what we get. Because it was just x ln x integrates by parts. If it was just ln x over e to the x, this is important to point out. If
X.
let me see.
No. It's gonna give you a
Yeah, it doesn't give one. I don't think that's interesting that gave you one of those because that's not a U substitution. That's what most of those were. So yeah, this, because it's got this product and this in here, I was going to say it could be possible that maybe you do it as a UDV kind of thing, where you let U be the log, and then you let the dV be you bring this up as e to the negative x, and then you let U be the log, and then you let, because I know I've done these before, but we're not going to do them, and the dV be everything else, so that'd be the x e to the negative x dx. So then when you do your integration by parts, when you do this antiderivative, you'd have to do another integration by parts on this first, just to get your v. But we're not going to have that, so we won't. But so, let's talk about one we would have to do. So let's say I gave you x over e to the x. Remember that e to the x could be brought up like this, because really for integration by parts, we want it to look like a multiplication, right? We want u times the dv. Right, and so we had that one on that other packet, or on those other ones earlier. It was this one here. That doesn't look like an integration by parts, but you bring the x squared up as an x to the negative 2, and then it's an integration by parts. Okay, so if it looks like a fraction, but there's no u substitution you could do, just bring that up like this, and then it would be an integration by parts. You'd let u be the algebra, the dV be the exponential, and then you could go from there. Okay, so that we could handle, but with that extra element, yeah, we can't. So that's interesting. That is the danger of the website. Sometimes those websites, they throw in some ones that might be beyond or something different than what we're doing. Most of the time, not though on that one. That's why if you stick with the book ones in the LH package, probably most safe. And there's a lot. All right. Well, let's do this then. Let's take some time, and then that can give you some time to keep doing some work on your own here, and ask questions. So I've got another page of review ones here for us to practice that would be similar to, give you a pretty good idea of the kinds of things you could expect on the gateway test. So, give you some time to work on those and help each other out if you want. Work on your own and compare answers if you want. Simplify further in the sense that the 3/5 minus the 1. Okay. You could do. All right, moving up. Okay, here's 4 and 5. far we got? Everybody through number 3?
No.
Okay. Raise your hand if you're through number 4. All right, let's talk real quickly about the first few of them here and go through those answers. And then I've got 3 more to put up there, and then we'll give you some work time on just ones out of the book and so forth. You can work together. But so this is a basic antiderivative. You're going to kick out a 1/6. Of course, the cosine is antiderivative sine. This is an arc sine with the square root. And then this one's just a power rule. Okay? And the answer to that one is right there. Right? Sine 6x, because the 6 is canceled, the 8 pulls out arc sine, and then that x to the -2 raises up to a -1, divided by -1. So it ends up being that. So the first one. Okay? Number 2 is one we just split apart. Right? Split that apart. So it'd be x cubed over x squared, that would just be 3x. And then the other one would be 3x to the -2 and do a power rule. So on number 2, you do your power rule and it ends up being that right there. And then when you put your 5 in and you put your 3 in, you get that. But it is not a natural log, right? It is not a natural log one. Okay, because you ended up with 3x, and then what was it? Minus 3x to the -2, right? That was what you ended up with when you split it. So this one you'd raise up to a 2, divide by 2, so that's 3/2 x squared. And then this ended up being 3 over x squared, but that is not a natural log, is it? Okay, that's a power rule. If that was 3 over x, then yes, that'd be 3 natural log. So it's 3x to -2. So you raise that up to -1, divide by -1, and make that a plus, and then be 3x to the -1. Now, I think when you go and plug these numbers in, I think you want to write this as a 3 over x then, right? When you go to plug the numbers in. I don't think you want to leave them as negative powers. You do want to simplify this. When we're evaluating, we want to evaluate and reduce, simplify that down to whatever number we can the best. So you put a 5 in here, that'd be 25 times 3, 75 halves. Put a 5 in here, that'd be 3/5. Parentheses are important. Put a 3 in here, 9, that'd be 27 halves. Put a 3 in here, that'd be 3 over 3, which is 1. 75 halves minus 27 halves, that would be 48 halves, I think. Did I do that right? And then, remember, this would become negative, and that would become negative. Right? Add the opposite. And 3/5 minus 1 minus 5/5, that'd be -2/5. No. Yeah. -2/5. Now we need to get a common denominator here. Right? And if you get one like this, I mean, and you very well may, we need to do this. Right? I mean, this is where some simplifying come in. Not algebraic, but numeric. So 10 would be your common denominator. So I would make this into 4/10. And I would multiply this by 5. 40 times 5 is 200. 8 times 5 is 40. So that's 240 over 10. So 200. Well, this would be, that's silly. What am I doing? It's Monday. Well, that's right. I just like to make things harder. It's good. It's more challenging for my brain. Because at my age, I might get Alzheimer's and I need to keep my brain working. So 236 over 10 would be 23.6. Or 23 and, what, 3/5? Or I could have just done 48 divided by 2 is what? 24. 24 minus 2/5 would be 23 and 3/5. Okay? So anyway, yeah, that was silly getting a common denominator right there. But it worked. Uh-oh. I just broke my marker equipment. Yes.
How did you get that 3x out of that?
the 3 what?
3x part, the very first part.
This?
Yeah, after the integral.
The original integral was 3x cubed over, wasn't there x squared on the bottom?
I must have not wrote it down right. 'Cause I
Oh, maybe I did it wrong.
I had 3x over x squared, so I was just missing the 3.
Oh, yeah, let's go back to it.
Yeah.
Yeah, missed the cubed. Yeah. Oh, yeah, then that would have been an ln.
Yeah.
Because you'd have had, oh, yeah, you showed me that. You had an ln in there, didn't you? I didn't remember. Yeah, and that would have. Okay, number 3, what are you doing there? You substitute the inside, because the du would be 9a squared dA, and there's an a squared dA right there, so then you're going to end up with u squared on the bottom. So when you do that substitution on number 3, so you let u be that inside, you get 9a squared dA, you're going to divide the 9 over, 1/9, and you get 1 over u squared, which is u to the negative 2. Now notice I went ahead and changed those to 4 and 28. I plugged my 2 into here, 27, or 8 times 3 is 24, plus 4 is 28. I plugged my 0 in here, and I got 4, so that's how I change those. Raise that up to -1, divide by -1, so I get -1/9 and 1 over u. So I plug those in. I got this. Again, common denominators. You know, I'm not saying it's going to be on there, but it sure could be, and you don't want to miss it just because you can't do some 7th grade fraction work, right? I mean, you want to be able to do these things. So that's why in these practice ones I've put a few of those on there to make sure, you know, we can do that a little bit. And that reduces to that. Or I could have went from the u back to the a's, plugged those back in, and then used my 0 and 2. It's going to come out exactly the same either way. Okay. Was number 4 an integration by parts, I believe? You got an algebra, the 8x. Now, you could pull the 8 out, but I prefer to just leave it with the x and make that be the u, the algebra, and then the trig here would be the dv. That would be the rest of it. You could let u be this inside, but the problem is you'd have an extra x here, and that would get into something you don't want to deal with. I mean, you'd say, oh, you could solve this for x, and yeah, you could, but you still got that cosine sitting there. We never really did a solve for x one unless it was all just algebra. That's really the only time we solve for x. So this is the integration by parts, algebra and a trig. So we're going to let u be the algebra, and it's going to look like this. So we'll let u be the 8x, the dv be this. Now, you got to be able to remember, here you're just going to kick out a 1/2, so I've got that. And don't forget this 8, we do not divide that 8 over, right? We talked about it last week. In an integration by parts situation, we're doing our formula. U times v, so that's this. So the 8 times the 1/2 is a 4. So u times v minus the integral of v du, that's these two multiplied together. Well, 1/2 times 8 is 4, so I went in and pulled that out. My minus, I don't know why I wrote plus and negative there, but it's minus the integral. And then all that's left is a sign. And so you're going to kick out a 1/2 again. So I kicked out my 1/2 here. The antiderivative sign's negative cosine, so that's going to cancel that negative. And so then I put it all together. So I have 4x sine 2x minus 8 plus 2 cosine 2x minus 8 plus c. Okay, integration by parts. And again, I'll put a link to this on our website so you can pull this up and look at it. Okay, that was number 4. And then I also had number 5 up here. 5 is actually a little actually is a simpler one if you get the right thing to do, right? And what are you going to do on this one? Let u be what? To u substitution, what do you let u equal? Tangent, right? Because the du of tangent is secant squared, which is sitting right there on top. And what's that bottom? 1 plus u squared, which is an arctangent, right? It's an arctangent, but that's what you're thinking of. You're on the lookout. When you see one like that, you think, hey, wait a minute. I could have a 1 plus u squared here. That's an arctangent if I let u be the tangent. Okay? So let's go down and look what that ends up looking like. So I let u be the tangent. The du is a secant squared, which is right up there on top. So that'll sub out. I end up with this. I get arctangent of u plus c, arctangent of tangent. What's arctangent of tangent? What's square root of x squared? X. What's ln of e to the x? ln of e to the x is x. What's arctangent of tan x? Type this one into your calculator. Let's see if it gives us x. It might, because there are some domain restrictions possibly there that the calculator may say something. It gives a warning sign, but does it give x? Yeah. If you type that one in, I think it gives you x, but then kind of a warning sign of things. If I had this one on there, and you had that left at that, I'd probably accept it. Okay, because we said that the algebraic, or in this case trig simplifying, not a huge deal. Okay, let me give you the last few here. Here's 6 and 7. Why don't you just copy them down real quick? 6 and 7. I'll give you number 8. I only have 8 of them on this group of work here today. And this is just some stray mark here. I don't know what that is right there. That was just some stray pen mark. I did a lot of scribbling on this when I made these. I'm not quite sure why. But so jot those down. Okay, and number 8. Is that? Okay, so go ahead and work on those 3. If you get those 3 done, you want to just get started working. Then somewhere here towards the end of the period, I'll come back and talk at least about one of them. I want to mention some things, and then I'll have this on our website, so you can look at it some more. But then the rest of the assignment is to go back that 23 through 33 or 73 in the book. All those, the 8.1 has a few. I circled some of those on that assignment sheet. They're the LH packets, right? Those different pages have a bunch of practice ones you can do.